Yes, now program evaluation and review technique is the last part in this project management, which is very common in any exam. You get one question from this topic in any examination attempt. So this particular technique is applied when the project is completely new. The project whatever you are taking up is completely new. So especially R&D case, we launch quite a new projects. So in that case, what is the problem is, since you don't have the prior experience, you are not sure of what is the time required for your activities. At the same time, if you are unable to calculate for the activities what is the time required, so naturally overall project duration also is uncertain. So that is the reason what we do is, in this type of projects, we estimate the duration of the activities first. We estimate the duration of the activities, then we based on that we calculate the project duration. Based on that we calculate the project duration, and then we will compare whether that estimated project duration is in line with our target date or not. So definitely a project should be completed within a particular time frame. So whether that estimated duration of the project is within that time frame or not, that is what we are going to check. So for new projects, always the biggest challenge is knowing what is the duration for each of the activities. So this is calculated with the help of three types of three types of situations, like best, worst, in between, like that. What we are going to do is, the duration is calculated with the help of these three factors. What are those factors is optimistic, most likely, and pessimistic. So these are the three scenarios which we consider, and we give weight to them and then calculate the weighted average duration. So this we do it for every activity. So under this technique, since we are not sure of what is the time, what we do here, expected duration is calculated for each activity as follows. How we are going to calculate for each activities? We are going to take three factors here, that is optimistic, most likely represented by TM, pessimistic represented by TP. So these are the three times which we are considering here, the time according to three factors. So what is optimistic, what is most likely, what is pessimistic? So we can say pessimistic means here, what is the meaning of pessimistic? Here you can treat it as worst case scenario. It is like worst case scenario. In worst case scenario, what is the time? Okay, and then in best case scenario, which is called as optimistic, best case scenario, what is the duration? And in between these two, the normal one, most likely. So for every activity, what we are going to do is, we are going to consider three times according to these three scenarios: optimistic, pessimistic, and most likely. And then we are going to give weight to each of this. So here the weight given to most likely case is 4. So what is the reason for giving 4 weight is because it exactly falls under the category of normal distribution curve. So exactly it falls under normal distribution curve, where the most likely scenario divides this normal distribution curve into 2 equal halves. So the weight given to this one is 1, for this one is also 1, for this it is 4. Okay. So generally in the regular class we spend some time on why these weights are taken as 1, 4, 1, but here since it is revision, just know the formula here. So This is how we calculate the weighted average, the expected duration of every activity, considering these three factors. So based on this only we calculate for every activity what is expected duration. Based on expected duration only we calculate what is the critical path and what is the project duration. Floats, so crashing, everything is done based on this only. So PERT is this only, program evaluation and review technique is this only. So we estimate the duration and then rest of the things are normal only. Now since the risk here is, biggest risk here is because you are estimating the project duration here, there is a possibility of risk. What is the risk is, tomorrow your actual time may deviate from the estimated duration. So what you need to do is that risk factor should be lower, So that risk is measured through standard deviation. So what is the possibility of your actual time deviating from the estimated duration? Even that is also calculated under PERT. What is the reason? Because whenever you are taking expected, naturally your actual might vary from that. So what you would like to do is, you would like to minimize the risk. So that is the reason we also calculate standard deviation under PERT technique. So how do you calculate standard deviation of each activity? This is the formula. So time according to pessimistic scenario minus time according to optimistic divided by 6. This is how we calculate the standard deviation of each activity of duration. We are finding out the duration, standard deviation of each activity. Then how do you get variance? Variance is the square of the standard deviation. Variance of activity duration is square, right? So this is for individual activities. Now if you want what is the standard deviation of the critical path or project completion, what is the standard deviation of entire project means, then how to calculate that? Variance of critical path or project completion is sum of variances of critical activities. So if you want to what is the variance of the critical path or project completion, you should take the sum of variances of critical activities. So whatever critical activities are there in the critical path, you should add each critical activity variance, and then on that if you apply square root, then you will get standard deviation. First you should get the variance, then you should apply square root on that to get the standard deviation of the critical path. So don't forget, if you want to get standard deviation of critical path, don't add the standard deviation of individual activities. Don't do that. First you should get the variance of the critical path, then on that you should apply the square root. Alright, so what you have learned so far is under PERT technique, we estimate the duration of each activity, and based on estimated duration only we calculate the project duration also. Now since we are taking estimated durations, now our actual time taken might deviate from what? Estimated duration. So we would like to know what is the risk of our actual time deviating. So naturally what we would like to do, we would like to have a lower risk or not? Yes. So for that purpose only what we do is we calculate standard deviation for the critical path. Even we can calculate the standard deviation for the individual activity. If we calculate for individual activities, then only we can calculate for the entire project. So you need to calculate a standard deviation, especially in these scenarios, that is new projects. Now after that what we do is we use normal distribution table to find out the probability of range of data. So what we do is, say for example we got project completion time 24 days. Okay, then we would like to know what is the probability of our project duration less than 24 or more than 24, because our actual project completion time can be less than this or more than this. So what is the probability of that? I would like to know, because The reason is because we are not 100% sure of the estimated duration. So that is the reason what we do is we apply normal distribution table in order to find out what is the probability of our project duration above our estimated or below our estimated or falling within a range. So now whenever you want to know what is the probability of a particular range of data, say from positive figure to infinity, then generally we use normal distribution table. One more reason why we use this normal distribution table is the data, whatever the probabilities, whatever we are calculating here, the data, whatever we are calculating, estimation time we are taking for each of the activities here. So those data, if you plot on the graph, that will reflect the normal distribution, that will take the shape of a normal distribution curve only. The data, whatever we are considering as a part of estimated duration, if you take that and plot it on the graph paper, that will reflect a normal distribution curve only. So that is the reason we are using this normal distribution. Not only in this case, whenever you use, whenever you want to find out probability of a range of data which is continuous in nature, we use normal distribution, because most of the time this will reflect this will give accurate results only most of the time. Yes. So now once you calculate standard deviation, now based on that, what we need to do is we need to, if they ask you in the question what is the probability of completion of a project in a given duration, then we use normal distribution table. So let us understand more about this also here. Why we are using normal distribution curve here? To find out the probability of the duration, whatever we got, project duration we got. Now what is the probability of achieving that duration, or more than that duration, what is the probability? That we would like to know, because we are not completely sure of our project duration. So with the help of normal distribution table, we will find out that probability. So how your normal distribution table will look like is this one. It will be a bell shaped curve here, and here it is exactly symmetry, so you can equally divide both. So this side area will be equal to this side area. So now these are, here we take the x values. X value is nothing but whatever duration of the project we got here, that we consider here. So whatever we would like, the probability of which data we are trying to find out, that only we will consider here. Okay, and this side is negative infinity, this side is positive infinity here. This is called as left tail, this side is called as right tail here. Now area under the curve is equal to total probability. So the total area under this curve, what is the probability of that is, it is equal to 1. Since it is divided equally, so this side you will have 0.5 probability, this side you will have 0.5 probability. So first I am trying to explain this table here, normal distribution curve, and then how to ascertain the probability. Then we will take our questions. So the entire area is equal to 1 here. As total probability is always equal to 1, total area is equal to 1. As the normal distribution curve is symmetrical, the area to the left and right is 0.5. Symmetrical means equal. Okay. The area form a value of z from standard normal variable. It is to be checked from area table and or given in the question. So what we need to do is, first, say for example, I got 24 days as my estimated project duration. This is my estimated project duration. Average figure this is. So which we can call it as mean, represented by mean. So I am taking 24 days here. Okay, X. So this is exactly the mean. Now if I want to know what is the probability of this project taking more than 24 days, that I would like to find out. Now first what we need to do is, we need to find out what is the standard we are calculating standard deviation also, no? Yes, now you will know what is the purpose of calculating standard deviation. We need to calculate the standard deviation of the project completion. Yes, say standard deviation of the project completion is 4. Okay, this is standard deviation. For 24 estimated duration, what is the standard deviation is 4. The standard deviation is 4. Now what I would like to know is, if what is the probability of a project time greater than 24, I would like to find out. So that means what I would like to find out from greater than 24 means this side I would like to find out, from greater than 24 to infinity, that range of data probability I would like to find out. So then what you need to do is, first you need to calculate Z value. What is Z value? Z value represents the Z value represents how many times your X value is from your mean. How many times your value, whatever you want, is from the mean, from here. So that is what Z measures here. Z measures how many times your X value, whatever desired value is there, from mean. What is the number of times it is from the mean? That is what you can find out from Z. So Z helps us to know what is the distance of your value from your mean. So now after that what we do is, using our Z formula here, we will find out the value of the Z. Then by referring to normal distribution table, we exactly find out what is the Z value. Okay, yes. So what we need to do is, first, what are the steps under this is, first you need to calculate expected duration of each activity. Then based on that you should find out critical path, and critical path duration also you should find out. The next thing is, we should also calculate what is the standard deviation of every activity, Tp minus T0 divided by 6. Then variance also we should calculate. Then based on that you should calculate what is the project standard deviation, project completion standard deviation. Once you calculate that, now you are ready with the mean value as well as standard deviation. Both you are having now. Now if you want to know what is the probability of achieving exactly 24 or more than 24 or less than 24, you want to be sure of, okay, your project completion time. So since this is estimated, whatever we are calculating, now you would like to know what is the probability of achieving, what is the probability of your project greater than this 24 or less than this 24. If probability is say 90%, you are getting that it is more than 24 only, more than 24. Then if in case if you have to complete your project within 24 days, and if the probability is more than 24 is 90% means, so definitely you should not take up that project, because going by this normal distribution table, the probability of the actual completion time is more than 24 days. So why we have to calculate probability? I hope you understood now why we have to calculate probability here. Just to know that whether my expected project duration is within the target whatever I have in my mind or not. To confirm that only we calculate the probability. So normal distribution table will help us to calculate this probability. That is what you should understand. Now to calculate the probability, first what you need to do is, first you need to calculate the Z value here. What Z represents is number of times your value, whatever value you want. Say for example, what is the probability of project completion is 25 or 26 days you want. So now 26 will stand here, 26. So what is the probability of this 26 I want? So then what I need to do is, I need to consider for 26 what is the Z value first I need to calculate. Then based on Z value, I can calculate what is the probability. Once you calculate Z, then looking at the table, normal distribution table, then we can calculate the probability. And not only that, one more important point is here, since due to symmetry here, the positive Z value is equal to the area of positive Z value is equal to area of negative Z value. The area of positive Z value is equal to area of negative Z value. So the area of Z is equal to 1 is equal to the area of Z is equal to minus 1. That means say for example, if this is 1.6, now 1.6 is the area here, positive I got, Z value is 1.6 I got. So whatever area we get for 1.6, the same we get for even minus 1.6 also. So automatically for minus, it will be the same value, only thing is negative value. Due to symmetry, that is, due to symmetry, whatever we get the area for positive Z value, the same will take for negative Z value here. So normal distribution table, you should know what, you should understand what exactly is mean and what is the standard deviation. Here mean represents the average duration of the project, whatever we calculated earlier, that is called as mean here, mean, because that represents the average. Okay, and exactly what is the standard deviation of the project also we calculate. For that average duration we also calculate the standard deviation. Yes. So using these two we can calculate the desired figures based on the question whatever they give you. So first what we need to do is, say for example 24 days is our project duration, and for 24 days I got standard deviation of the project completion time is 4. Now if they ask you to find out what is the probability of our project taking more than 24, if they ask you more than 24, then what we have to do is, we have to calculate first Z value. Then based on Z value, we will refer to the table and we can find out the probability of that particular question. So these are the steps. So to give you a full clarity here, what I have done is I have given the steps here. I hope with the help of steps easily you can calculate here. See, first of all, people should have an understanding of this normal distribution table. If you have the knowledge of normal distribution table, then easily you can understand what they are trying to do here. Already logic I told you why exactly we are using this normal distribution table is because the data whatever we have taken, estimated data, with the help of that only we are calculating the probabilities here. So that data if you plot on this graph, that will reflect this normal distribution curve only. That is the reason we are using this normal distribution. Yes, so see the steps here. First thing is find the value of x whose probability is required. What do you need to calculate? Find the value of x whose probability is required. That is what I was saying. Say for example you want a probability of completing the project in 20 days. Then 20 days will become our x value. Next, compute z value using x. Compute z value using x. So in our normal distribution curve, this is only our x value. So horizontal line is only our x value. Okay. And below that we take z value. Z value represents the number of times your x value from your mean. So z score we have to calculate. So at this point mean will be there. So below that you have the standard deviation exactly. So now we have to calculate what is the probability of probability of x value we have to calculate. So step number 1 is, first you should know what is the x value. Then based on that you should calculate z value. What is the formula for z value is x minus mu divided by standard deviation. Here mu represents the average duration, that is whatever the critical path duration is there, that is only mu, which we calculated based on estimated duration. This is standard deviation of the critical path. Standard deviation of the critical path. So mu represents duration of the critical path. This one represents standard deviation of the critical path. So which is 17 and 4. Assume now it is 17 and 4. Assume just 17 and 4. Now you want to know what is the probability of completing the project in 20 days. So 20 becomes now your x value. So substitute now x is equal to 20 and what is the project duration we got? 17 divided by standard deviation is 4. So you are getting z value how much? 0.75. So how to represent this 0.75 is, z value is 0.75. So positive, no, this is negative infinity, 0.75 here. So you want a probability of find the value of x was probability of complete project in 20 days, within 20 days. That means you want this area exactly. You want the probability of completing the project this is the area what we want. Probability of completing the project within 20 days. So this is the area what we want here. So what you have to do is you have to refer to the table. So tables also, you have 4 types of tables, normal distribution tables also. One is standard normal distribution table. One is standard normal distribution table, one tail, two tail. Other one is cumulative normal distribution table. So 4 tables you have. So depending on which value they have given in the question always they will provide you the z value. But z value is of which table also you should know. Z value of which table also you should know. Accordingly you should make adjustment. That is also a big challenge here. If they give you cumulative distribution table, then what does it represent? If they give you standard normal distribution table, then what does it represent? Remember now, if they give you cumulative distribution table, normal distribution table z value, then it will always give you value from minus infinity to x value. If they give you cumulative table z value, then it will give you from minus infinity to the x value up to x it is going to give you. So in this case, if they are giving z value directly, they z value of 0.75, positive 0.75. So directly they are giving from minus infinity to 0.75. So that is only the answer. In case if it is a cumulative distribution table. If it is standard normal distribution table, then it will give value from mean to x. So at mean the value will be 0, z value will be always 0. Here I have to plot now because these are x values. So horizontal x value, no. So here it is at mean, what is my project? 17 here. They asked you to find a 20. Within 20, what is the probability of that? So z value, if you calculate at mean, z will be 0. Okay, from here we are trying to calculate now. At mean the z value will be 0. So now for 20 days we calculated, now for 17 we know what is the standard deviation. Now z value, sorry, for mean what is the z value? 0. Now for 20 we have to calculate z value, and what we got? 0.75 we got. So we want this area now, probability of this area we want. So whatever value you get for 0.75, that is only our answer. In case if they give you cumulative distribution table value. So here we have to find out what is the probability of your project completing less than or equal to 20 days. Because project is completed within 20 days even when it is completed earlier than 20 days. So Z less than or equal to 0.75. How you should represent this is how you should represent this one. This is X value, this is Z value. I told you that this is mean, no? Mean represent your critical path duration, 17 days. Below that you can take the Z value. At mean exactly Z value will be equal to 0. Now here, if they give you standard normal distribution table value, that give value from mean to X value, So here, from 0.75 value from standard normal distribution table, assume that they have given standard normal distribution table, the value what they have given is 0.2734. Z value of 0.75, which table? Standard normal distribution table value they have given. So then what is the meaning of that? Is that gives you value from 0 to only the X value. But I want this area no completely. So we know that this area will be equal to 0.5 no. So what we should do is whatever value they give you, to that value add 0.5. Then you will get the probability. In case if it is a standard normal table, if it is cumulative, then they will give you from minus infinity to X value only. Directly that value only you can take. So this is the first example. What is the probability of completing the project within 20 days? What is the probability of that? Is 0.7734, nothing but 77.34%. Now next, so we are assuming that 0.2734 is from which table? That is standard normal table. So that is how we should first calculate the project duration, then standard deviation, then you can calculate the probability of completion of your project within a particular time frame. Okay, so we have a question here. This is the past examination question. Using this question, you can understand the calculation procedure. Before that, I hope this normal distribution table you should understand here. For calculating the probability, you are using that. First of all, what clarity you should have is to calculate the probability of the range of data. Range means what? From positive infinity to X value, or from X to positive infinity or X to negative infinity. So this is called as range of data. So for finding out probability of this range of data, we require normal distribution table. So in order to calculate probability using normal distribution table, you should know what is mean, what is standard deviation. That anyhow first we have to calculate that only. Then Z value you should calculate. Once you calculate Z value referring to the table, you can calculate the probability. So this is what you have to do. These are the steps. Okay, I hope you understood the steps here. So once again you can refer to the steps. What are the steps? First you should calculate, find out the value of X here, for whom we are calculating probability, whose probability is required. Then compute the Z value using X. Once you calculate the Z value, okay, then referring to the normal distribution table values, we can find out what is the probability. This is what you are supposed to do. Next, one more type of point what they give you is duration of a project at a given probability. Sometimes they will only give you probability. What they will do is they will give you probability and they will ask you to find out the X value. Reverse question this is. Earlier, when they give you x value, we found out probability, no? Now certain questions, they will give you the probability. We have to calculate what is the x value. See here example, duration whose probability of completion is 95% they have given. Project completion probability is 95% they have given. Now, for what project time it is 95% probability we have to calculate. If z is equal to 1.64, z is 1.64, area between z is equal to 0 and that value is 0.45. So now what we need to do is basically we have to calculate x value. From the probability we have to calculate x value. Now they have given probability 95%. How they might have got 95 is probably they got value here, this value 0.45. See here. You can exactly identify here. So they've given probability 0.95 means here for the standard normal table value whatever we get, to that we add 0.5 now. Yes. So see here what they have given is z figure they have given, z is equal to 1.64 exactly at mean. We don't know what is this. This is what we have to calculate now. This is mean, this is average duration, not that one. X value we have to find out. This is project duration, that is. Now at this the z value will be 0. Now what they have given is z score they have given. Z score is 1.64, positive 1.64. Exactly at this standard deviation, what is the x value we have to find out. Okay, we know that if they give you normal, standard normal distribution table, they will give you value from here to here only. Up to here they will give value, only this value they will give. To the given value we add 0.5, no? So what we can do is from 0.95, remove 0.5, that means 0.45 we are getting. What we are getting? 0.45, that means the z value 0.4 corresponding to which z figure we have to find out first. Okay, that, so z value we have to find out. Because in the question they have not given z value, they will not give you z value. We have to find out first z value. Once you find out z value, then from z value we can calculate the x value. Once you get the z value, substitute in z formula, then you will get x value. Okay, so what is this question is, generally they will give you x value, we have to find out probability, no? But reverse question, they will give you probability, we have to find out what? X value. So for that what we have to do, that is what I have given here. First what you do is, for the given probability, first to find out z value. How we can do that is by referring to the table. How? Now it is 95% means what we might have done, already 0.5 we might have added here. 0.5 we have added to 0.95. So remove that point for 0.5, then take 0.45. Going to the standard normal distribution table, see 0.45 value. 0.45 value is corresponding to which z value you have to refer. Then you can find out what is the z value. So by referring to the standard normal table, the z value is equal to 1.64 at 0.45. Okay. Now z value we got. Now go to the z formula. Z is equal to, formula is there, z is equal to x minus your mu divided by standard deviation. So you will be knowing this one and this one. Now z value also you know. Now you can find out easily x value, right? So once you get this, the required probability is 95%, the duration will be greater than your critical path, z value will be greater than 0. So 0.95 probability is equal to 0.95 area under curve, 0.5 plus 0.45. So 0.45 area value z is equal to 1.64. So that if you substitute in z formula, then you will know what is the x value. X value is 24 days. So even I have written how to do that. Okay, majority of the students, what is the problem they face is they fail to understand this Z value and normal distribution table. My dear students, I told you just now, there are 4 types of tables. Okay, generally in SFM, I teach students completely about this normal distribution table so that they will have full clarity here. Since I am giving you full concepts only, I will try to explain this Z value, because some of you, how many tables I told you? 4 tables. 4 tables you will find, normal distribution tables. So in this notes complete quickly, I will in 10 minutes I will give you an idea of this normal distribution table. Then easily you can identify the Z value, probability of Z value. The difficult part is that only for students. Okay, remaining all is easy only. The difficult part is finding out the Z value only, interpretation of Z. So I told you that when you will use normal distribution table is used to calculate probability of range of data. So if you want to calculate, say example, normal distribution table to calculate probability in following situations. What are those? So what is the probability of price moving up higher than Nifty 16,500? So what is the range here from 16,500 to infinity? This is the range of data. Or what is the probability of NPV of a project being negative? That is from 0 to what? Infinity, negative infinity. This is called as range of data. So whenever you want to calculate for this kind of range of data probability, or what is the probability of price of ABC share remains within a range between 500 to 600, or what is the probability of getting marks in a particular subject above 85. Here the range is 85 to 100. So these are the scenarios where you can use normal distribution table. Now, so let us try to calculate the probability now. Okay, what we will do is we will try to calculate the probability of getting marks in SFM, say higher than 85 marks. Okay, what is the probability of getting marks higher than 85? So for that we take entire past data, past students, how many marks they got. You can see different marks. So entire data we take from 85 to 100, whoever got, we take that entire data 85 to 100. Then what we do is we calculate the probability of each of those marks, say 30 marks, 40 marks, 50, 60, 70, 80, 90. So what is the probability of 30? Then what we do is from the past data, how many of the students got 30 divided by the total data, number of observations I will take. That is how I will calculate the probability of 30. Similarly for the rest of the data I will also calculate. So this data, whatever we calculated here, the above distribution of marks is a normal distribution. If we plot the above marks and probability of on graph paper, then it will make a bell-shaped graph. If you plot all those marks here, 30, what is the probability of that? 40 probability, 50, 60, 70, 80, 90. You can see that bell-shaped curve you will get. This data, whatever we taken here, if you plot it on a graph paper, this is how you will get the shape, bell-shaped curve. So here 60 represents the mean. Mean marks the average marks. So how do you get this average? Average is nothing but the summation of each possibility multiplied by their probability. If you multiply exactly, you will get 60 only. So 60 is your mean, nothing but average. This is your average. Okay. Now interpretation according to statisticians is, this is the mean, exactly it is dividing now. So this one equal space now. So the total probability of this area is 0.5, the probability of this area is 0.5. Total probability of this range is 50%. That is minus mean to minus infinity. This is mean. And the total probability of this is also 50%. And what is the range of that? From mean to positive infinity. Okay, yes. So the table distributes this probability for each small area. So as normal distribution table provides probability values, it also termed as normal probability distribution table. So if you want to find out area under normal distribution curve, this is what we were doing till now. Yes, area under normal distribution curve is measured or denoted by Z. If you want to find out the area under normal distribution, we have to find it by Z. Z is the number of standard deviations from mean. What is Z? That is what I was telling you earlier. Z represents the number of standard deviations from mean. So example, if Z is equal to 2 times, if standard deviation is 14.5 marks, because we calculate the standard deviation of our average marks, it is 14.5. So that means what? Area under normal distribution curve is 29 marks from the mean. The area under the normal distribution curve is 29 marks from the mean. So that is what is the meaning of Z value. If mean is 60 marks, then it represents area from 31 to 89. You can see here. If your Z is 2, if Z is 2 here, Z value, this one, if it is 2, the 2 represents what? That is what is given. So if you multiply with standard deviation 14.5 into 2, it is 29 marks away from your mean. That means 60 plus from mean, 29 marks more. To that add 29. So 89. So that is what Z denotes. So Z denotes what? Number of standard deviations from mean. So how far, what is the figure of how far from your mean? That is what Z is going to measure. Z will measure how far your value is from your mean. Yes. If it is positive 2, then you will add. If it is negative, you will deduct from 60. This is negative. So what is the formula to calculate Z values? X minus X bar. X bar is nothing but your mean. This is standard deviation. X is the desired data from which Z is to be calculated, and X bar is the mean data, average, standard deviation. Both positive Z and negative Z probability remains same. Positive and negative probability remains same only. We ignore negative sign in Z. Keep in mind negative Z is equal to left tail area. Positive Z is right tail area. Now this is how your table will look like. Table provides probability of each small area of the curve. Each and every area in your curve, okay, will be given from this table. So if Z value is equal to 0.1, say if it is 0.12, then how to see this Z value in the table is 0.1, 0.02. So this is the value. This is how we look at the Z value. This is the probability. 0.12 probability, how to check? 0.1 under this 2. This is the probability. So this is the probability of Z is equal to 0.12. Okay, this is the area under the normal curve. So I told you that there are 4 types of probability distribution tables. Now different types of normal probability distribution tables is 4 different types you have in the market. If you see all the tables, first one is standard normal table, second one one tail table, third one two tail, fourth one is cumulative table. Earlier I was using standard normal table, standard normal probability distribution table. This table will provide area from X to X bar. X to X bar means that is from 0 to Z area. From 0 to the Z area it is going to give. Only from 0 to, from mean to the Z value only it is going to give the area. From 0 to Z or from X to X bar. So this one, this X bar is nothing but average now. So from here to here only that table will give value. this value it is going to give positive. The same thing you can take negative also, from x bar to x, negative z. So table value only will provide this value only. Now if you want this value, what we have to do? From 0.5 remove this value, automatically you will get this one. Greater than means this one, less than means this one. No. So if they want greater than x, then this one I want. Table will give you this value. Are you getting? Especially if it is standard normal table. So if you want to get the value of your probability, then what we are supposed to do, that also we will know. First you know table interpretation, how we interpret the area. One tail probability distribution table. This table provides probability of area from x to infinity. So it will give, one tail will give you from x value to infinity, it is going to give this value. From x value to infinity it is going to give you. Which table? One tail table. If it is negative z, this side. Okay, this is one tail table, right tail or left tail. Then two tail probability distribution table also will be there. So two tail probability distribution table, if positive z is there, that means table provides the sum of probability of these two areas. That means from here to here. So this one, this value put together, that is the value the table is going to give you. Okay, I am indicating by red mark here. If it is two tail table, the z value will cover both this one as well as this one. From 0 to x bar to x here, this value plus this value, both you should add if it is two tail table. If it is cumulative probability distribution table, then it will give you from minus infinity to x value, or minus infinity to z if it is z score. This is cumulative. Generally they will give you either cumulative distribution table or standard normal distribution table. Remember these two. Now what adjustment you should do here? See, this is cumulative. So that means from here to here they will give you the value. This table will provide probability of this area. Okay, minus infinity to x they are going to give the value here, z value. Okay, now if you want to calculate now what is the probability of getting marks higher than 85 in SFM, say average is 60, you want more than 85, no? So that means x is 85, so this I want, probability of this area I want now, probability of this area I want. Okay, depending on the table value now, first we should calculate z value. Let us calculate z. Standard deviation is 14.5 marks, x is 85, so mean is 60. So you are getting 1.72. 1.72 z value, that is. Z value we are getting here. Z value exactly here is 1.72. Now depending on the table we should adjust this z value. Say if you are referring to standard normal distribution table, z value will give you directly from where? From mean to up to here it is going to give you area. If it is standard normal distribution table, then what we should do? If you want this area, then what we are supposed to do? We know that from this to right hand side complete probability is 0.5. From that remove the area, this area, whatever value they gave in the table, standard normal table, then you will get value of what? Probability of this area. Again I am repeating. So I want this area. They will give you, if it is standard normal distribution table, they will give you area from here to this one. So what we have to do to get the probability of this is, we know that probability of complete right side is 0.5. From that, remove the value given, this one given, no, then you will get this one. So if they give you standard normal distribution table, probability of getting marks greater than 85, how you can get is, as I told you, 0.5 minus the table probability whatever they have given. If it is cumulative, what I told you, cumulative means they will give you from minus infinity to up to here, they will give you, no, from here to here they will give. The area of the table will give from here to here. I want this value, then what I can do, total area I know it is 1 probability, from that you will remove this, then you will get this area. Probability of the entire area is 100 or 1. From that you remove this area, automatically you will get this area if it is cumulative. See the last one, if they give you cumulative table Z value, then what you do is from 1 you deduct the table value, whatever is given in the question. Then you will get this area table. So I advise you to remember these two tables, how to adjust the values. In case if they give you cumulative, they give you the value itself is the probability. If they give you standard normal, they will give you only from mean to x value only they are going to give you. So to that you should add 0.5 other side. Okay, yes. So these are the 4 types of tables. So either they might give you cumulative table or standard normal table. So please remember that. Now coming back to our questions. So I was showing you how to interpret the Z value. Now this is past examination question. Each activity they have given optimistic time in weeks, most likely time, and pessimistic time also given. First you should draw the project network, then find the expected duration and variance for each activity. First, for each activity what you should calculate, expected duration. What is the formula for expected duration? Do you remember? T O plus then 4 Tm plus Tp divided by 6. This is the formula to calculate your expected duration of each activity. Then standard deviation, how do you calculate? Tp minus T0 divided by 6. Variance, how do you get? The square of this. This is how you get the variance. Then after that find the critical path and expected project time. Then after that what they asked is, what is the probability that the project will be completed in 23 weeks? What is the probability that project will be completed in 23 weeks only? X value is given. They also gave you Z values here. If you see Z values here, 1, 1.9, 1.9 to 0.9713, 0.97 means definitely this is cumulative only. This is cumulative table only they might have given, no? Yes. So project network network diagram you can do it, that is not a problem. Now calculation of expected duration for each one, for each activity. First you take activity and TP value, TM value, TO value, all three they have given now. From that you calculate expected duration using the formula. Then standard deviation you calculate, then variance you calculate. That is what they required in the second one. Then critical path. What do you have to calculate? Critical path. So for this you require network diagram. So what is the critical path here? Which critical path is nothing but the path which gives the highest duration here, that is only your critical path here. So critical path here is 1 to 2, 2 to 3, 3 to 5, 5 to 6, 6 to 7 is critical path, which is giving 20 days. Now you want critical path standard deviation you want. How to calculate critical path standard deviation for each of these? First you should take the variance, add all those variances, then apply on that square root. That is how you will get a variance of a critical path. On that standard deviation if you apply, square if you apply, you will get standard deviation. So 1 to 2 variance is 0, 2 to 3 variance is 1, 3 to 5 variance is 0.45, 5 to 6 0, 6 to 7 1. I have taken from here only variances of all these critical activities in the critical path. If you add all of them, you will get total 2.45. Then on that square root if you apply, then you will get standard deviation of critical path 1.56. Okay, so now you know critical path, which is our estimated project duration completion time. And we know even standard deviation of critical path also. Now what is the first question is, what is the probability of project completion? 23 weeks they've asked. What exactly is the question here? The probability that the project will be completed in 23 weeks. In 23 means what? Within 23. So less than or equal to what? 23 or less than 23 weeks. So what is our x value here? 23. So first what we should do is we should calculate the z value for that x. So if you calculate z value for that, how much you are getting? 1.923 you are getting. Z value is 1.923. What is the project completion estimated? 20 days. They are asking now, what is the probability of completing within how many weeks? 20 weeks, no, that 23 weeks. This is what they want. Now z value, this is x value, no? Exactly at this point z value will be 0. So what is the z value at here? Question mark, we have to find out. Okay. So what is the z value here? 1.923. How much we got? 1.923 z. So they want probability of less than or equal to 23. So I want this one. So this I want. Less than or equal to 23. This is what we want. So for z is equal to 1.923, you got z is equal to 1.923. Okay, what is the probability? What is the area under this curve? So what is the area? Directly if they have given in the question only 1.923, 0.9726. That is the probability. Completed. That's it. So table, if you know correctly table interpretation, easily you can get. Okay, yes, so this is your program evaluation and review technique. Sometimes what they will do is they will give you the probability. What we have to do is we have to find out the x value. So what you will do is first, in that case, first you find out z value. How to find out z value is by referring to the table. Probability they have given now. Use the table z value. Substitute in z value, z formula you substitute, then you will get x value. Remaining things you will be knowing now. Yes. So I hope your concepts got revised, my dear students. In case of new projects, which technique we will apply? PERT we are going to apply. So what are the steps in this case? First you should calculate for each activity estimated duration using the formula TP plus TP plus TO plus TM. So what is the weight we will take? For most likely case we take 4. What is the meaning of that also? I told you. Optimistic means best scenario. Pessimistic means worst scenario. And other one is most likely scenario. So by applying this formula, T0 plus 4Tm plus Tp divided by 6, weighted average this is, you can calculate the estimated duration of each activity. Then you should also calculate standard deviation of each activity and then variance from that, so that you can calculate the variance of the critical path also. Variance of critical path is not of individuals. What you should do is, first you should add all the individual critical path activities variances. That is how you will get what? Variance of the critical path. And how do you get standard deviation of critical path? Is you should apply standard deviation on variance of critical path, but you should not add the individual standard deviations of the activities. Okay, after that, how to find out the probability of completion of a project in a given duration? First, for that x value you should know, then z value you calculate. Referring to the table, find out the z value. Depending on, there are two types of tables you might get. One is standard normal table, other one is cumulative table. Okay, standard normal table, other one is cumulation table. Right, thank you students. So this is project management. See you in the next topic.